Hello everyone, my name is Arwa. In this video, my group member and I will present to you the real-time computing, and we will talk about introduction, real-time architectures, real-time issues, real-time operating system, real-time communication, fault tolerance in real-time system, and application. Computing has emerged in real time as an important branch of computer science and engineering. Characteristic of real-time application: timing. Time is very important factor in real-time application. Ability to predict restrictions. It should be possible to appear in all designs since need for predictability has a large impact on all design of real-time system. Has dependability, performance constraint. Application have to meet certain reliability, availability, and performance requirements. Real-time architectures. We have two levels, node level and system level. At the node level, each processor must provide the speed and predictability, deal with the provenance, interaction with the external world. This can be achieved by making operation such as implementation of the instruction, the number of memory and context switching to make this operation more predictable. At the system level, we have two major issues: communication internode and fault tolerance, that make it difficult to achieve the ability to predict. Real-time issues. We have two levels, high-level architectures and low-level architectures. At the high level, the distribution system consists of a set of nodes communicate through a network interconnection. Memory subsystem may also have to be carefully designed to provide a fast and reliable communication between processors in a node. Routing algorithm can use advanced technology such as virtual switch routing, cut through the hole, and the package don't always have to be stored in the intermediate nodes before they are sent to the next node in the route. At the low level packet processing, routing, control error flow. In a distributed real-time system, there are additional issues like support deadlines and time management. Since the support of these low-level impede the implementation of application, tasks, and nodes in real-time system. Network processor performs the operation necessary for the delivery of an important message from the source to the intended recipient. Now Hanouf will explain for you input-output architectures. Input and output architecture. Most of the work has been focused in distributed computing system, interconnection network, program and communication model, and algorithm. However, little has been done specifically for input and output subsystem in real environment, despite its importance. The computer can real-time data processing speed of not more than it can get the data from the sensor and the operator. Input and output device in real-time environment are sensor, actuator, and display, while they are a disk and a magnetic tab for general-purpose system. Input and output hardware should be used to be distributed and managed by controllers is relatively simple and reliable. Multiple access methods are used for improved access reliability and performance. Real-time operating system. Unlike traditional operating system, the ability to predict is one of the main requirements for the operating system in real time. It's important to provide support for context switching, speed and quick handling from the provenance, and scheduling with timing and reliability constraints. Operating system can provide this support be classified into three categories: kernels, small and fast; intended for small applications such as embedded device peripherals, smart and control and simple process, chimerical operating system with real-time extensions, provide a familiar interface with support for moderated system in real time, are usually slower and less predictable than kernels. It's perfect suitable for development of large software and applications, and play a key role in development of the operating system in the future. Operating system oriented research, weak to support ICOs that are not their focus. Real-time communications. 1. Multiple access network. The protocol carrier sends multiple access collision detection that apply to the network first in, first out. The local node transmits a message using the policy of its own local scheduling. Each node has two watch, real clock and the virtual clock. Real clock run along the axis of time and keep the elapsed time on each node. Virtual clock run only when the channel is idle, and when it's run it does so at faster rate than the real clock. The problem with multiple access network is that they are vulnerable to single point of failure. 2. Point-to-point interconnection networks. Contrary to what happened in the multiple access network, and not all pair of nodes in the topology connectivity from one point to have direct contact between them. So, maybe some message to be relayed by one or more intermediate nodes before reaching their destinations.
Hi, I'm Victoria Laiban. Today I'm going to talk about fault tolerance in real-time systems and application. First of all, the fault tolerance, a relationship between fault tolerance and real-time computing. There is a common misconception about the real computing that the fault tolerance is orthogonal to the real-time requirements. But it's often assumed that the availability and reliability of system requirements can be processed independent of time constraint. But in another hand, the validity of the system depends not only on the health of its outcome, but also to meet the strict time requirements. And sometimes it may fail to real-time system to function properly. The logical correctness of the system may be dependent on the health of timing of certain component, but the separation of the technical specification and timing specification is very hard. 2. Space and time trade-off. Systems are often characterized by design the fault tolerance system by a trade-off between time and space redundancy. Most of the methods focus on improving the space, but in real-time computing, the tendency would be to trade space for time, and since meet strict timing constraints is essential to ensure the correct behavior of the system. Must be considered a reputation in the context of achieving all of the predictability and reliability of the system. For example, assume a transient error by retrying a count is acceptable method. Inaccurate account approach is one method to sacrifice accuracy for time to improve the iterative calculation. Two applications, real time. There is three applications: real time control system, real time artificial intelligence, and real time database. One real time control system. Digital computers are commonly used in control system in control systems in real time is mainly due to improve performance and reliability in dealing with increasingly complex control process. To real-time artificial intelligence, there has been a growing interest in application of these techniques for control systems in complex real world involving hard deadlines. In such systems, the controller is required to respond to some of the inputs within rigid deadlines, or the system may fail. Three, real-time database systems such as facilitating the implementation of the expanded and open software architecture for real-time systems and applications will help in real-time management of large amount of the database and information sharing between tasks. Most traditional database systems are disk-based and used for recording traditional and secure protocols.